right, good morning, guys. I want to go over how we simplify radicals. All right, so this is something that most of you remember had to do from Algebra 1. Hopefully you guys talked about in the spring, but it's good to just kind of, clear out some cobwebs and say, oh yeah, I know how to do that. So we know that we have right here the square root of 36. When we have a nice perfect square like this, it's really easy, right? Because we know that the square root of 36 is going to be the square root of 6 times 6, or the square root of 6 squared. The square root and the squared kind of cancel each other out, so we're left with 6. So that's nice and easy. So when we have a square number and you have those memorized, it's really nice. But some of us don't have those memorized, or we just don't know. And that makes it a little harder. So for example, if we have 72, I'm going to show you two different ways. The first way actually deals with knowing those perfect squares. So if you know the perfect squares, then you can think about, well, what perfect square goes into 72? And most of you will say, well, that's 36 times 2 makes 72. Awesome. Hey, wait a second. I know that 36 is really 6 squared. So I can rewrite this as square root of 36 times the square root of 2. And I know that this 36 square rooted is going to be 6. So I'm left with 6 root 2. Some of you are really going to like this way. So for example, let's take the square root of 45. If I think about what perfect squares go into 45, I know that 45 is 9 times 5. So that means square root 9 times square root 5. Well, the square root of 9 is 3. So the answer is going to be 3 root 5. And that is the reduced radical. All right, there are times when Big Ideas is going to force you to type in the reduced radical. So I just wanted to review how to do that. That's way one. Let's look at the second way. The second way is when we have the square root of a number and we make a factorial tree listing out everything that goes into making that number, all right? So 72, I know that that is 36 and 2. I know that that is really 6 and 6. And I know that 6 is really 2 times 3. All right, that's what 72 is. Now you have to take it all the way down to the primes, okay? And then when I rewrite this, I'm going to rewrite it as 2 times 3 times 2 times 3 times 2. When we do the pairing method, once I have all the prime factorization written out here, then I'm going to go through and I'm going to find buddies. And the best way I can describe this is it's like the square root is a jail or a goaler or a prison, something like that. And in order to escape, they each need a buddy that matches themselves. If they don't have a buddy, they can't escape. So this 2 can get out. So he's going to be able to leave. This 3 can get out too. He has a buddy. So he's going to be able to leave. But this 2 is stuck. He doesn't have a buddy to escape with. So he's stuck inside. So then I can rewrite this as 2 times 3, which is 6, root 2. You'll notice it doesn't matter which way you do it, you get the same answer. So if we try it with 45 again, 45 I know is 9 times 5, but 9 is really 3 and 3. So when I rewrite this, I'm going to have 3 times 3 times 5. Then I have to ask myself, can anyone escape with a buddy? Yes, 3 can. So 3 will be able to get out, and 5 cannot. He gets left behind. So we have 3 root 5. Doesn't matter which way you prefer to do it, but I just wanted to review that really quick. Let me know if you have questions.